For 11.3, we're going to determine if three sides of a triangle form a right triangle and find missing sides. So what does that mean? Remember how I told you, even if it looks like a 90-degree angle, unless it has the what, we can't say that for sure it is. What is it? So if I give you this triangle, can you assume that that is a right triangle?
Yeah. No. No.
No. Why? What is it missing?
The square.
The little square that tells me that's 90 degrees, right? We cannot assume anything about the triangle. But what can I do? I can determine if something is a right triangle by plugging in the sides into the Pythagorean theorem. So if I plug the sides into the Pythagorean theorem and it works, is it a right triangle? Yeah. If I plug all the sides into the Pythagorean theorem and it works, then it's a right triangle. Because remember, the Pythagorean theorem only works for right triangles. If I plug it in and it doesn't work, is it a right triangle? No. Yeah.
So if it works, you'll be able to.
So then I wrote it really big for us. Do not judge by the picture. I want you to underline that right now too. It's in all caps, it's start, and now you're going to underline it. Do not judge by the picture. You may not assume anything in math. You have to prove it. Okay? So let's look at example 1. Okay, example 1, I have to decide if this is a right triangle or not. Now, is this one a right triangle?
Yes.
It tells us yes, right? Let's double check this one. We know that this is a right triangle, so when I plug everything into the Pythagorean theorem, it should work, right? So let's double check it. So which one is a leg? 3 is a leg, so that's 3 squared plus, what's the other leg? 4 equals 5 squared. 5 is called the what? Hypotenuse. Okay, what's 3 squared? 9 plus 4 squared is 16 equals 25. What's 9 plus 16? So we get 25 equals 25. True? Yes. Okay, so this is for sure a right triangle, right? What we are going to be given mostly is for example 2. There is no picture at all. Okay, so example 1, we knew it was a right triangle because they gave us the 90 degrees. What they could have done was given us the triangle without the 90 degrees and just the measures, and we would have had to plug everything in to say yes or no, it's a right triangle. Okay, we knew this one was a right triangle because they gave it to us. We were just double checking. Okay, what we're going to see in example 2 is 3 numbers, and we have to decide whether or not this makes a right triangle. How do I know which one is which? Did you guys notice about anything about the triangles we've been working so far? About the hypotenuse? The bigger number is always the hypotenuse. So whenever we have just 3 numbers, that bigger number is always your hypotenuse. So let's write a note there. Biggest side is always the hypotenuse. Okay, so the longest side is always the hypotenuse, because let's think about it. If this is 3 and this is 4, it takes a lot longer to get from this corner to this corner, right? In every single right triangle, there's no right triangle that you could make that has the shorter hypotenuse. Okay, so how would I plug this into the Pythagorean theorem? 7 is a leg, so 7 squared plus 9 squared equals 12 squared. Okay, the longest number is always the hypotenuse. Okay, what's 7 squared? 49 plus 81 equals 144. Good. Okay, what's 49 plus 81? 130 equals 144. True or false? False. So is this a right triangle? No. Okay, so let's look at example 3. I want to use the Pythagorean theorem in right triangle KMP, so that's KMP, so that's this triangle right here, to find the length of LM. So I know that KMP is a right triangle. Okay, I also know if KMP is a right triangle, what about triangle KML? Is that a right triangle? It is. Let's think about it. If I have a line, what's the angle measure of just a straight line? Does anybody remember? 180. So if I cut it in half and tell you that this side is for sure 90 degrees, what does that have to make this one? Also 90 degrees. So since this guy is a right angle, this guy is also a right angle because it's just a straight line. So what could I do to find the length of this side? Jerry? We can plug it into the Pythagorean theorem. If I was just given this triangle, I can't assume that it's a right triangle, correct? Because they didn't give it to me. But since they share a side, and I know that this one is a right triangle, I can assume that this one's a right triangle. Does that make sense? Okay, so LM is going to be our x. And then I just plug everything in. So that is, one leg is x, so x squared plus, the other leg is 15, so plus 15 squared equals 25 squared. Okay, x squared plus, what's 15 squared? 225 equals 25 squared? 625? Okay, now what? Subtract 225. So x squared equals 400. Now what? Jerry? Take the square root. Good. So x equals, what's the square root of 400? 20. And that's it. Does that make sense, guys? Is that okay? Okay, question. What if they had asked me to find the length of MP? What would you have done? Pythagorean theorem, but using 15x and 17, right? Okay. What if they asked you to find the length of LP? Jerry? Yeah, you find the length of MP, you find the length of LM, which we just did, and then you add them together. Does that make sense? Not too bad? That's it, guys.